speaker, Mr. Alampay, is the president and founder of Digiscript Philippines, a firm that pioneered the use and adoption of 3D high-definition survey in the Philippines back in 2009. With 3D technology, they bring solutions to architectural, engineering, and construction industries. They are able to create 3D models with an accuracy of up to millimeter, which helps document and preserve Philippine cultural heritage sites for future generations. Mr. Alampay conducted detailed engineering studies for 13 damaged heritage structures and churches after the Bohol earthquake in 2013. Besides that, he also worked together with a lot of other cultural gems like the Manila Cathedral, Rizal Monument, San Sebastian Basilica, Fort Santiago War Tunnel, and many more. Please join me in welcoming our next speaker, Mr. Conrad Alampay.
One of the technologies that our organization, Digiscript, our company, has been able to introduce to the Philippines, and we are now currently using it for many, many applications, one of which is what we call heritage preservation. So, of course, I'd like to thank, of course, the organization and STEM Expo the first time. This seems to be a success, and I hope to be here maybe in the coming years, succeeding after this year. So, thank you again for organizing this wonderful event. I want to open up with a very interesting scene that you might have seen a few years ago if you're into watching movies. It looks like this.
Looks like a Baptist preacher. Tactics. Looks like a Baptist preacher.
It's pageantry going on here, lots of theater.
Close.
The heat from the blast was in excess of 3,000 degrees Celsius. Any subjects within 12.5 yards were vaporized instantly.
No bomb parts found in a 3-mile radius of the Chinese theater.
No, sir.
Time to be happy.
Do you all remember the scene from Iron Man? So he's now immersing himself into the crime scene that was scanned in 3 dimensions.
Any military victims?
Does that seem too futuristic at this point, or do you think this is possible today in this time and age? I'm happy to tell you today that this is something we somehow can achieve. It may not look like this in the movies, but this is something that is already being done in the country and for the things that we're doing. So we can now visualize ourselves in 3D space using laser scanning. And this is exactly what has been shown you in this Iron Man clip. We are already in the digital age. So all of us, I think, are carrying a mobile phone that's a smartphone that can now access information anywhere we go and give more intelligent information from what we see in structures. And this is an exhibit in a museum that are now integrating our devices into in the digital space. In terms of when we say 3D reality capture, it's now using different types of sensors, whether it's our cameras, our certain scanner imaging, into capturing when you say reality, it's what's around us, our surroundings, and bringing that into a digital space such as a workstation or a computer and visualize it. So we're now integrating different types of technologies in our company, especially focusing on actually 3D laser scanning, or what we call LiDAR. I heard earlier today while I was waiting, there are some organizations or groups already using LiDAR in their experiments, into their projects. So that's nice to hear. And this is exactly what we do. It's called LiDAR. 3D LiDAR is the scientific term. And what is 3D laser scanning? So we'll focus basically today what is 3D laser scanning and what can we do, what can we use it for to help different applications. So LiDAR, or 3D laser scanning, is a surveying method that measures distance to a target by illuminating a target with a pulsed laser light and measuring the reflected pulses with a sensor. So it's almost like like what we have our laser pointers. When you use a laser pointer, it will bounce off a surface and return that as a measurement point. The only thing that's different with this is it captures your 3D space 300 or 1 million points per second. So that's very, very different than how we've done things traditionally, which is 1 point at a time. This one now captures your 300 or 1 million points per second. And this is an introduction of, I wanted to share with you how it works for digital preservation or heritage preservation.
Digital preservation is a process that utilizes new technologies in surveying and imaging to document heritage sites to accuracies that were never before possible. Before these advancements in technology, documenting a heritage site meant utilizing simple tools like a measuring tape and a drawing pad to construct a drawing. Since then, intermediary developments like theodolites and electronic distance meters have allowed this process to become faster and more accurate, but we were still collecting individual points that had to be brought together manually and interpreted as a drawing. Today, we can document a site in 3D using a laser scanner, which sends out a pulsed laser beam that hits the surface of a structure and records the precise coordinates of that point. The laser scanner does this so quickly that it is able to record hundreds of thousands of points a second, capturing a high-resolution reading of all the surfaces around it. It was in the 1990s that civil engineer Ben Kassira gathered a team of experts to develop the first portable 3D laser scanner that would revolutionize the way we document heritage sites. Kassira first developed this technology to monitor infrastructure and nuclear power plants. But his longtime interest in cultural heritage pushed him to create the nonprofit organization STEMx in order to digitally preserve the world's cultural heritage sites by developing a complete documentation process using this brand new technology. To fully capture a heritage site, millions and even billions of individual data points are captured and merged together to create what's called a point cloud. Because of the accuracy of each recorded point, the complete point cloud is essentially a high-resolution, three-dimensional model of the heritage site. Once this digital model is complete, it can be utilized in many different ways. It can be used to help preservationists study the site in more detail, as well as provide educational materials and virtual access to people across the globe through the internet.
Okay, so we've come a long way from that video. You've seen how the old laser scanners were. They had at least 5 people to move those laser scanners around. But today, you're in for a special treat. I'm going to show you one of the latest top-of-the-line laser scanner systems that it's actually the first in the country now. We'll be bringing it out. You'll see how big a difference it is from the olden scanners in the past, where you needed 3 or 4 people to bring that around. So in the country today, where is this used? Actually, in terms of general applications, where is this used? First of all, it's primarily used for architecture engineering. So normally this is a tool that's used during construction. When you capture your facilities, it will measure everything within the building once during construction and for design. You've seen earlier that video how it's used for cultural preservation and archaeology. Interestingly enough, this technology can be mounted on drones or unmanned aerial vehicles, or what we call terrestrial scanners, which is on the ground, which is really what we are using currently today. So it's also used for law enforcement, not just because you saw it in Iron Man, but it really is used by the police. The crime scene investigators use this tool to document crime scenes after there's an incident, so that you can preserve the evidence. That's how it's used also. You can also use it for safety planning. So what happens in this case, you would map out a building or an environment, and you can now analyze the entire structure, line of sight analysis, and also help plan out exit routes if you have scanned the entire building. This is the fun part where you've seen it used in entertainment. If you watch Lord of the Rings, the Weta, the production company, uses this to scan large hectares of land and bring that data inside the set. So you see the hobbits at the background. Looks like they're on site, but that's laser scanned and brought inside the studio. So that's been used also for the entertainment. The good thing is that this technology is still quite new. It's evolving, and there's a lot more applications. And I think from the collective efforts here today, I'm sure there's going to be a lot yet to be discovered, and you'll be able to find your own applications, how to use this technology for the benefit of others. In the country, however, there are several applications that's already been used. I'll share a few of ours, but in general, one of the biggest LiDAR 3D laser scanning projects that happened here several years ago, or had just concluded, was the UP Dream LiDAR project, which was where they mounted a LiDAR system, a 3D scanner, on top of an airplane and mapped out the entire Philippines. So that data was able to generate hazard maps, topography, terrain, and helping us plan for these natural disasters or flooding in the future. So that's one of the projects that the UP group initiated under the DOST. And in our case, we're also showing you how we're using for documenting our priceless heritage, which is something we care about a lot, and something that we have to work very quickly on because we are losing our heritage sites. So this is what a lot of the applications, one of the applications we've used it for the Manila Cathedral, which is very close to here. In 2012, there was some structural problems that was encountered, and before any engineering work could start, they needed first to document the entire building. So we brought the laser scanner and moved it around at several locations, and in a matter of 5 days, we were able to capture the entire structure inside and out. So once we scanned everything, we now combine all that data, we stitched everything, and you will get a complete 3D rendering. So what you're seeing in front of you now is not a recreation, it's not a 3D graphics creation, it is the actual Manila Cathedral documented inside and out, and anywhere now that we need to measure off, we have a complete measurement point which is now documented, and now this is where we produce what we call the engineering drawings or architectural drawings extracted from the precise measurements from this. I failed to mention that the laser measurement can range from 300 meters away. So when we set up on a tripod, we can scan entire 300 meters away and measure that safely from the ground, so we don't have to raise scaffolds to document. It's much safer and easier to reach the top, the spires and the towers. And in an actual project, this is how we would move it around the building. You will notice that every few meters we would set up a scanner so that they would overlap. The overlapping points are our tie points that help us create a 3D picture of that entire structure. Right? So it happens in a matter of, I think, 6 to 7 minutes per scan, and in a matter of a few days we were able to show you that 3D Manila Cathedral. As I showed you, it has a built-in camera, so it also takes imaging on top of the laser measurements. So anything virtually that I open up on my computer from scanning, after scanning, can be measured in front of my desktop. So anything there is measured, and I take a point-to-point measurement, capture an elevation. And what's important there is also the architectural details. In conservation, we need to capture all the details and help understand how to preserve it. So this is what we call a laser scan point cloud. The data that's collected from all the different locations are comprised of millions and millions of XYZ points, which we call point clouds. And on the left, you'll see the actual raw data that is used to generate these drawings. And from here, we extract what we call feature extraction inside CAD software. Computer-aided design software is used to open up this data, and we can now generate a complete documentation of the facade. So much so, if we zoom in, we'll actually see quite a lot of detail. So this is the basis for this as a starting point for a lot of the conservation architects, the engineers. How do they now understand it? They will use these drawings to help analyze it, understand the structure's integrity, and now document it for the future generations. This is now a visual walkthrough, a 3D animation walkthrough of the Manila Cathedral. captured from 3D scanning. It will give you impossible views, virtual views, and even let you walk through walls. So imagine anyone who has not seen the Manila Cathedral, you can imagine exactly what it looks like now by walking through the doors and seeing it this. So all this data is digital data, made up of those point clouds, which means anything that's digital, I can now cut and slice any which way, and the next shot will show you a cut down from a top-down view. So I can extract layer by layer and visualize the entire configuration of the plan of the church. Right. So these views, which is something that you've probably never ever seen before until today, because this is what laser scan data allows you to do. I'll just step back a bit, and I'd like to share one interesting project with you, which is the Bonifacio War Tunnel. This is actually along near C5, in front of Market. Again, not very far from here. This is a very historic tunnel, and it was built during the American and Japanese War in 1942. The interesting story here, this was actually built by General MacArthur, but it so happened that the Japanese had arrived, and this tunnel was taken over by the Japanese. And this shares a bit of history during that time. This goes down 17 meters underneath C5. And you'll notice we were able to enter there, but currently it is now undergoing a rehabilitation plan because they plan to turn this into a historic war museum in the future. But we had to do the initial study for the group, for the BCDA, and if you have not had the chance, I'll take you down there right now. So this is the tunnel as you enter. It is actually around 1 kilometer in length. But stories say that it was around 2.2 kilometers. But since the construction in BGC has expanded, we have already covered most of the actual tunnel itself. But these are the chambers that you would see if that would have been used by the Americans during that historic time. See on the bottom right, you'll see this is now the Japanese expanded tunnel. The Japanese had taken over this tunnel and expanded it another kilometer from this point. And so again, once you have laser scan data, this is not just used for engineering, but it'll take you through and preserve this data for future generations. Okay. And the whole idea is, how do we use this? How do we make this historic information relevant to the youth today? Some of the things we're trying to develop now is sharing this data online, putting them on apps, make history books jump out of you. So instead of just sticking to text, we can now virtually take you down through these historic sites by putting them on devices that we already carry today. So the sites I've shown you, they have been preserved, but unfortunately, we are losing heritage sites every day due to calamities, demolition, urban development. So it's difficult to restore them if we don't have a way to preserve them. So you remember the 2013 earthquake in Bohol and Cebu. So as a result of this, of course, lives were lost, but also our priceless heritage. And this is what encouraged me and our company to be able to help document. We don't want this to happen again. The time this happened, there was very little documentation of these sites in Bohol and in Cebu. So this was a lesson learned for us. We don't want to wait for this to happen before we now understand and preserve our history. So these are some of the images and scenes that you may see from the earthquake that we were a part of after. So after the earthquake, we worked very closely with our National Museum to now document what was left. So we captured what was left there, the damages, conducted a damage assessment. This was the site in Giwan after the Yolanda. So we had a back-to-back calamity. As you remember, 2013 was a difficult time for all of us. And the physical manifestation of that was also the churches. So we were there as a group, as a team, to go on site, bring in the scanner, understand what the extent of the damage was, and preserve what we could digitally. And what's interesting from that data, we are now able to share this, put it online, and document through drawings and as-built, what we call as-built, of the current structure. And again, make them more visual, understand them in a different way, in a different perspective. This is just another view. So once you captured it in immense detail, you are now looking at, we can now compare the before and after, and what we can show in the future. So on the right, you'll see the current state of the Lobok Church. And on the right, you'll see whatever was documented, we have rendered it in 3 dimensions to show you the complete contrast of both areas and what it could be in the future once we restore it. We are here today for the engineering industry, and really it's created a lot of other applications, and it's changing the way how we measure compared to the traditional way, and we get much more information, and it's really about how to analyze that data. Right, exactly how we change the way we design. So the trouble nowadays for designing is sometimes we don't know what was actually on site. But when we know it from multiple perspectives, we can now bring in a team. It becomes more collaborative with architects and engineers, and we have a proper baseline starting point. I'd like to say that it does make learning exciting and entertaining. For me, history was never my favorite subject, but after capturing it in this rich detail and this exciting way, it makes it more interesting. You can analyze your structures more and immerse yourself in it, which is even more important. So once you are able to understand something more, you can now be more creative and encourages collaboration from multiple parties. And we really believe that at the end of the day, we want to work with technology that really improves the lives of others by helping improve the places around us. So hopefully once we see this technology being deployed more and more in the country, we'll hopefully start to see an improvement around our surroundings of our roads, our bridges, our infrastructure, our housing developments. This is something that we can hopefully realize once we have been able to understand what's actually on site. And through cultural preservation, is able to help us understand and rediscover our past, preserve our current, but also plan for its future and preserve it. I'd like to leave you with this one slide, which is, he who does not know how to look back at where he came from will never get to his destination, which is something I believe truly is, if we don't look back and document our past, how will we ever learn? And this is actually something I truly believe in, and this is something we also scanned back in a few years ago. The Rizal Monument, as we documented it in this rich detail as well. So I have one little treat for you. Earlier today, we were able to get the opportunity to bring in our laser scanner. So that's this device here. You'll see how small it is. So this is what we call the laser scan BLK under Leica Geosystems. So Ponzi, my brother, who's joined me today, he's just pressed a button and shown you in around 2 minutes this little device, which is as big as, smaller than the microphone, will document this entire space in 2 minutes, and we'll show you the results. So it also has, the way this works, so you may not see the laser, but it's now shooting around the structure, around the room. It also has a built-in camera, so it's now documenting photographs together with laser measurements. And that's what we're capturing right now. So as you notice, they're built and comprised of millions of points after the scan. And we'll have Harry, our resident expert, zoom into a point and show us. So if you zoom into a point, you'll notice that it has a XYZ coordinate. It's a 3D point in space. And he'll now take point-to-point measurements of your screen right here. And just a few buttons, you have automatic measurements of your entire, of your projector board. You zoom in. So again, you have measurements, precise measurements to the millimeter. I can zoom out. Actually, I will show you a zoom out, fly around, Harry. You're able to fly around like a mosquito around the space. So, of course, we were scanning when there was movement around. So the people that were moving, you are now ghost effects in our scan. And then we also have, I mentioned color, Harry. So why don't we quickly activate the color? So that was it was quite a bit dark, but you want to pull back and get onto the. I mentioned how it's used for engineering, right? So in architecture, if I zoom out, I can now generate a floor plan. In a matter of a little bit of movement, I can now generate your as-built floor plan, count how many chairs there were, measure end-to-end the walls. And that's really how engineering today is going to be done. And I'm happy to be here today to share this with you. You're the first, I think, students who are actually seeing this. Maybe later this afternoon, I stick around for a few minutes and you can have a look at it, press the button and scan if you'd like. But this is the first of this type in the country. It's been, the first ones were as big as that box, the first scanners. So you can tell how long we've come a long way now to make it this small, this compact, and this easy to use. So with that, I'm very happy to take some questions and be here for this afternoon. Thank you again.